Hello everyone, this is Professor Keen once again. Let's continue our discussion of Stellarium software, which allows us to do desktop stargazing from the comfort of our own home. Okay, so we have been talking about the motion of the sun through the sky over the course of the year. You might recall that the concept we're working with here is, from our perspective here on Earth, it seems that there is a large so-called celestial sphere to which the stars are fixed and which rotates around the Earth once per day. That gives rise to the impression that the stars are rising and setting, rising in the morning, setting in the evening. And the sun also moves along with the celestial sphere, but on top of that daily rotation of the sphere, it also has a gradual drift through the constellations, and as over the course of the year it moves through all 12 constellations of the zodiac. In fact, that was how originally the year was defined, as the amount of time it takes for the sun to drift through all 12 signs of the zodiac. So let's open up Stellarium once again. We are going to be viewing from Wauwatosa, Wisconsin. You can see here that we are looking southward. It is right now about 5:24 local time here in Wauwatosa. The moon is in the southern part of the sky. It's about a half moon, and the sun is setting in the west. Now let's go back and look to the east. Take it back. Let's look to the west, and let's add some markers here. Let us add our grid lines, and let's also add our constellation names and our constellation art. Recall the sun is in Leo right now. And what I would like to do is spend a moment refreshing your memory on how the sun looks over the course of the year. And so to do so, let's open up our sky and viewing options and show the ecliptic line, which is the line that passes through the 12 signs of the zodiac along which the sun moves over the course of the year. Nowadays, we understand this to be the plane of the solar system, and we'll come back to that later. Okay, so now what I want to do is open up my time and date window, and I will put it over here. Notice it is about 5:26 in the afternoon, and now what I'm going to do is quickly cycle through a year and show you how at about the same time, at about 5:30 or so in the afternoon, the sun is going to be at different locations over the course of the year. So you'll see here I'm moving forward in time. The sun, again, it's still about 5:30, but September, let's move this down a bit. It's October, November, by this time the sun will have already set in November. And in December, it will definitely have already set by this time. And then as we come back, January, it's still below the horizon at this time. February, it's moving through the signs of the zodiac. March, again, this is 5:30 in March. April, May, June. So right now we're about at the the summer solstice. That's where the sun will be at 5:30 on the summer solstice. And June, July, August. And so we're back to about where we are now. So let me go back to the present date. Okay. So that's just to remind you how the sun moves through the zodiac over the course of the year. And again, in that exercise, what we were doing is we're taking a snapshot, so to speak, of where the sun is in the sky with respect to the background constellations at about 5:30 in the afternoon. Okay, now what I want to do is challenge you a little bit and point out that we are doing all of these stargazing exercises from a point that's about 43 degrees north latitude on the Earth. That is in Wauwatosa, Wisconsin. And that is precisely why the lines of the celestial sphere are coming in at this angle toward the horizon, this line of the horizon right here. If we were at a different latitude on the Earth, then these lines right here, these latitude lines or the lines of declination, would be coming in at a different angle. So let's go to the location window. And instead of being right here in Wauwatosa, let's suppose that we were in Quito, Ecuador. Okay, we'll pick Quito, Ecuador, which is right here. It's right on the Earth's equator. How would things look different? Okay. Well, in Quito, Ecuador, now we're looking to the west, and it's about 5:30. It looks like the sun is setting. Now notice, I'm going to go back in time a little bit here. Let's go back to like 3:30. And notice now that these declination lines are coming straight in to the horizon. As we go forward in time, I'm going to let time move forward a little bit accelerated rate. Notice how the sun is setting. Instead of coming in at an angle like it did up in Wauwatosa, now that huge celestial sphere is rotating around us so that its latitude lines or its declination lines are coming in straight toward the horizon. I remember when my wife and I took our 10-year anniversary down to Aruba, which is closer to the equator. It's a little bit above Venezuela. But it was really fun to watch the sunset into the ocean from Aruba because it's uncanny. It's strange to see the stars, the sun, the moon set straight into the ocean instead of coming in at an angle. And yet that's precisely what happens when you're very near the equator. As the celestial sphere is rotating around the Earth, so to speak, we see the sun, the moon, the stars dropping straight down into the ocean. Okay. So that's what we see like that. I'm going to stop us for a second. And now let's look more toward the north. And notice now as we look to the north, and I'm going to let the time evolve here. Oops. Go a little faster. Notice what's happening is this celestial sphere is rotating around once again, but the North Star, that is the tip of the tail of Ursa Minor, is right on the horizon. That is, of course, because this celestial sphere is rotating about this pole star, which is above the north pole of the Earth. And since we're on the equator, that north pole is way off in the northerly direction. So this is precisely what one would see if one were looking northward from Quito, Ecuador. Right now it's about 2 o'clock in the morning, and so that's what you see. Again, if we look now eastward, the celestial sphere is rotating around us, and there the sun is rising straight out of the horizon. And there's morning, what it looks like in Quito, Ecuador. Okay, let's stop for a moment and go back to right now. Okay, so this is what it looks like in Quito, Ecuador. Let's go to a different location. Instead of someplace on the equator, let's go to someplace very far to the north. Instead of Quito, Ecuador, let's go to the northernmost town in the world. This is a town called Longyearbyen in Svalbard. I think it's in Sweden. Is it in Sweden? I don't remember, but it's up in this archipelago up here. And that's the name of the town. It's about 650 miles from the North Pole of the Earth. The latitude is 78 degrees north latitude. And so if we go to there, what does it look like? Well, right now it's August, right? And so now let's kind of look around. And as we look to the east, we see that these latitude lines of the celestial sphere are at a much shallower angle compared to the horizon. Okay? And if we look straight above us, that is where the pole star is, the North Pole. So if we were to move in time forward and look straight up above us, the entire sky would be rotating around the North Pole star, which is above us. Okay? And notice now what happens if you look toward the horizon. That huge celestial sphere is rotating around us like this. The sun is in Leo, and you'll notice we're in August. It's basically going to circulate around the horizon over the course of the day, and there will be some days over the course of the year that the sun never dips below the horizon. So right now we're about 3 o'clock in the morning, 4 o'clock in the morning, 5 o'clock in the morning, 6 in the morning, and so on. And now it's 9 o'clock, 10 o'clock, and it's about noon, 1 o'clock, and it's dipping kind of close to the horizon, just below the horizon. It's now 3 in the afternoon, and now it's about 5 in the afternoon. Now the sun is going to start coming back up, 6 in the afternoon. I hope this turns out all right on my video. I'm just kind of dragging us around like this. Now we're looking toward the east. This is about 9 o'clock in the evening, and so the sun's coming back up. Notice the sun never dipped below the horizon when we're up at this high latitudes. Okay, so that gives you a sense of the kind of strange sorts of things that are seen when one is at above the Arctic Circle. We'll come back and talk more about this over the course of the semester. Again, part of the purpose of this Stellarium exercises are to point you to some things that you can spend some time exploring to see what the sky looks like over the course of the year from different locations on Earth, and to get you, if you are not already familiar with stargazing, then at least a bit familiar with the sorts of things that one sees. Well, until next time.